Time to talk about VLSM. VLSM stands for Variable Length Subnet Mask, and the goal of this type of subnetting is to save as many IP addresses as possible. Let's look at the definition. So, unlike fixed length subnetting, variable length subnetting creates a hierarchical IP address space, making it possible to create subnets without wasting a large number of addresses. We're going to use the same example we used in the previous lesson, only this time we're going to adapt the mask when we get to the smaller networks. So we're not going to use the same mask for all 4 networks. So the request was to create 4 subnets where 3 subnets should have 5 IP addresses each, and 1 subnet needs 11 addresses. Let's remind ourselves what was the solution when we used the VLSM technique. We had 4/28 subnets, which means each subnet has 2 to the power of 4, which is 16 different IP addresses. And only in the first subnet, we actually needed that many IP addresses. In the other 3 subnets, we only needed 5 IP addresses. So let's look at the VLSM solution. Now for the first network, it's still going to be /28 because, as I said a minute ago, we need 11 addresses in the first subnet. So we're going to use /28 because that gives us 16 different IP addresses. The network ID also remains the same, so it's going to be 192.168.1.0, and the range is also going to go from 1 to 14. .15 is going to be the broadcast IP address. Now let's determine what's going to be the mask for the second subnet. The second subnet, just like the other 2, need only 5 IP addresses. So we can give it /29 because that gives us 3 bits for the host portion, which means we can create 2 to the power of 3, which is 8, different IP addresses for hosts. The network ID is again going to be the next free IP address after the broadcast IP address in the previous subnet. So the broadcast address was 192.168.1.15. So the network ID for the second subnet is going to be 192.168.1.16. The range will be from 117 to 122. Because this time we're only going to use 8 IP addresses. So for the other 2 subnets, it's actually going to be easy because the mask is the same. We only need to calculate the range. So for subnet 3, mask is /29. The network ID is going to be the next free IP address after the broadcast address of 192.168.1.23 from the previous subnet. And the range is going to go from 25 to 30. And then 31 is going to be broadcast for subnet 3. So the network ID for the 4th subnet will be 192.168.1.32. And the range is going to go from 33 to 38. Let's compare our VLSM results with the VLSM result. So this is VLSM and this is VLSM. When you look at the last IP address we used in the 4th subnet for VLSM, it was 192.168.1.62. And then the 4th subnet, or the last IP address in the 4th subnet, when we used VLSM, was 192.168.1.38. So this shows you how many IP addresses we actually saved only by using the VLSM technique.